The universe is huge, mysterious, and full of secrets that we've only just started to unravel. For decades, we've thought we know how the universe began, with a single explosive event. The Big Bang? For 13.8 billion years, this model has been the best explanation for everything we see around us today. But what if there's more to the story? What if the Big Bang wasn't the beginning of everything, but just one part of a much bigger cosmic story? What if the universe we live in is just one of countless others, merging and interacting with one another in ways we can barely comprehend? This might sound like science fiction, but recent discoveries have made us think again about some of the most basic ideas we have about the universe. And most astonishing of all, data from the James Webb Space Telescope is fueling a theory that is so bold, so transformative, that it challenges everything we thought we knew. Before we get into this game-changing idea, let's go back to the beginning, or at least where we thought it began, the Big Bang, a universe born from nothing. For a very long time, the Big Bang theory has been the foundation of our understanding of cosmology. The Big Bang theory suggests that the universe was born from a singularity, a point of infinite density and heat that compressed space, time, and matter into an infinitely small speck. Then, in an instant, this speck expanded, creating everything we know today. It might seem straightforward at first, but when you really think about it, it raises some big questions. How could everything, space, time, matter, have come from nothing? What caused this sudden explosion of energy and matter? Was there something before the Big Bang? Or did the very idea of before not even exist? The late Stephen Hawking, a renowned physicist, once quipped that asking what came before the Big Bang is akin to asking what's north of the North Pole. It's a futile pursuit because time itself began with the Big Bang. This view is that the universe came into being from nothing, so there was no time before it began. However, not everyone is in agreement with this. Some researchers actually believe that the Big Bang wasn't the ultimate beginning. They say it was just a transition, one of many Big Bangs that have happened across an endless eternal sequence of universes. This way of thinking introduces an intriguing and intricate concept, the idea of a multiverse. The multiverse theory suggests that there are other universes out there, not just our own. Instead, it's just one bubble in an endless ocean of universes, each with its own laws of physics, matter, and time. Some of these universes might be pretty similar to ours, while others could be totally different. The theory also suggests that Big Bangs aren't one-off events. They happen multiple times in different parts of the larger multiverse. It's possible that our universe was born from the collapse of a previous one, or from a collision between universes. This view suggests that the Big Bang wasn't the start of everything. It was just one event in a much larger cosmic cycle. But is there any proof to back up this pretty mind-bending idea? Is it possible that our universe is interacting with others? Up until recently, these questions were just that, questions. However, thanks to new technology and telescopes like the James Webb Space Telescope, we may be getting closer to some real answers. The James Webb Space Telescope is set to make some groundbreaking discoveries. Launched in 2021, the telescope was designed to peer deeper into space and further back in time than ever before. One of the main things it's looking to do is study the earliest galaxies and stars, which will give us a lot more insight into how the universe began. But it's not just this mission that's revealing new details about how the universe is expanding. It's also showing us things that have stunned scientists. It's been about a century since astronomers first realized that the universe is expanding. This was first spotted in the 1920s, when researchers noticed that distant galaxies were moving away from us. The further away a galaxy is, the faster it seems to be moving away from us. This is what's known as Hubble's law. But the more scientists have looked into the expansion of the universe, the more unusual things have become. Over the past few decades, we've also found out that the universe isn't just expanding, but that it's doing so at an accelerating rate. This discovery rocked the foundations of cosmology because it suggested that something, some unseen force, was driving this acceleration. Scientists have dubbed this enigmatic force dark energy, and it's believed to account for approximately 70% of the universe's total energy. But despite what its name suggests, we know almost nothing about it. Dark energy is still one of the biggest puzzles in modern physics. But what if dark energy isn't the reason for the universe's expansion after all? What if there's something even more fundamental at play? One of the biggest challenges in modern cosmology is something known as the Hubble constant discrepancy. The Hubble constant is the rate at which the universe is expanding. Here's where it gets tricky. Depending on how we measure it, we get two different answers. If we measure the expansion rate using the cosmic microwave background, the afterglow of the Big Bang. We get one figure, 67 kilometers per second per megaparsec. But when we measure it using supernovae, red giants, and variable stars known as Cepheids, we get a different value, 73 kilometers per second per megaparsec. This discrepancy has puzzled scientists for years, and no one has been able to explain why these two measurements don't match. Could it be a mistake with our equipment? Or is there something more fundamental we've overlooked? To get to the bottom of this, researchers are turning to the James Webb Space Telescope. The telescope recently observed 320 Cepheid stars in an attempt to get a more accurate measurement of the universe's expansion. What did they find out? The discrepancy is definitely real. There's no doubt about it. It's happening. But what could be causing this difference in the expansion rate? And this is where it gets really interesting. We've got a new theory, merging universes. In December 2023, a new study was published in the Journal of Cosmology and Astroparticle Physics. It suggests a new theory that could change how we think about the universe. The theory suggests that what we think is dark energy driving the accelerated expansion of the universe might actually be something else. So, what if the universe's strange behavior is actually the result of something far more extraordinary? It could be that our universe is merging with others? Yes, that's correct. This new theory suggests that our universe is currently interacting with other universes in the multiverse. And these cosmic interactions could be the reason behind the universe's accelerated expansion. The study actually suggests that our universe has been doing this for billions of years, merging with larger parent universes and absorbing them. If this theory is correct, it would completely change how we understand cosmology. The expansion we see may not be the universe growing in isolation. It could be the result of the universe increasing in volume as it merges with other baby universes in the multiverse. This idea may seem incredible, but it's not just speculation. The researchers behind the study came up with a mathematical model to show what would happen if multiple universes were interacting with one another. Based on their calculations, these universe mergers would result in a volume increase that matches what we see as the expansion of the universe. But there's more. The model also predicts how fast the universe should be expanding if these mergers are happening. Amazingly, the predicted rate fits even better with real-world observations than the traditional Big Bang model does. What does this mean for our understanding of the universe? If this theory is right, it means that the universe we live in isn't alone. It's part of a bigger connected system of universes, with each one influencing the others in ways we're only just starting to understand. This could help us understand some of the biggest mysteries in modern cosmology, like why the universe seems to be expanding faster than we thought, why we see discrepancies in the Hubble constant, and even the nature of dark energy. But how can we prove this theory? Unfortunately, it's unlikely that we'll be able to detect other universes directly with our current technology. However, there may be ways to find evidence indirectly. The focus now is on studying the cosmic microwave background radiation that has been traveling through space since shortly after the Big Bang. If universe mergers are real, they might leave some subtle marks on this ancient radiation, which could one day confirm the existence of the multiverse, a new era in space exploration. We are living in an extraordinary time for space exploration and cosmology. Telescopes like James Webb are allowing us to peer deeper into the cosmos than ever before, unlocking new mysteries and challenging our most deeply held beliefs about the universe. What we once thought was a simple story, a universe born from nothing in a single explosive event, is turning out to be far more complex and inspiring than we ever imagined. The idea that our universe is just one of many, that it's merging with others in a vast multiverse, opens up entirely new ways of thinking about the cosmos and our place in it. So, while we may not yet have all the answers, one thing is certain: the more we explore, the more incredible our universe becomes, and who knows, the discoveries of tomorrow could be even more mind-blowing than the ones we've made today.